Hello? Thank you. I think after a long time I'm speaking with Mike. It is a little bit different experience. Yeah. Yeah, I think, yeah, thanks for the introduction. And I was here for last 1 week. I'm traveling to Austin for meetings of a couple of people. And yeah, today we're going to talk about exploring the GPU workloads, especially how do we do the GPU testing. I think you may be hearing a lot of generative AI stuff over the presentations and how we are using generative AI. But end of the day, the generative AI workloads what we are talking about will be running majorly on the GPUs. How exactly we test the GPUs, how exactly we test the GPUs and make sure that GPUs are working fine. That's what we cover here. Using the generative AI workloads, we will try to test the GPU and make sure that how it performs. Okay. I have a video and all the stuff. I'll try to see where we can go a little bit faster to cover the video and demo and other stuff. But if you have any questions, feel free to ask me, and I would like to give you more details on that side. So yeah, I created specifically the slide which is more giving all the details about the flow and all things, but yeah, we will rush up somewhere wherever we wanted to a little bit more faster. So we'll give a little bit introduction to GPU. I think some of you maybe know, some of the people you would like to know more details, we'll give you. Then the difference between CPU and GPU, because you maybe heard mostly on the CPUs in your PC, but GPUs, what is the different, exactly how it works. And then we'll introduce to generative AI, what exactly the generative AI, how it works, what is exactly the tools and softwares. And then we'll talk about tools, and we talk about how do we do the load testing with GPUs, and we'll have a light demo in the band. And I know this is a little bit pretty heavy topic, and we will not able to cover all the things, but if you have any questions, anything, and we can connect on the LinkedIn, and we can talk about more on that side also. Okay? Yeah, sorry for that. So yeah, I think everybody knows most of times now, once the generative AI came up into the market after ChatGPT introduced, everybody got to know that, okay, this generative AI workloads, generative AI applications, text bots, chat bots, and all the stuff. The key thing which is rapidly growing in the backend is basically GPUs. If you look at one of the Nvidia share price, you will see that the GPU, what it is exactly taking over the market. So GPU was not introduced now, it was there long time, but it was very silent in the back end. It is majorly used for the video editing, gaming, and all the PCs basically, okay? But not in the regular enterprise. Basically it was in the gaming and video editing purpose. Used it actually. It's a specialized device. It performs more than CPU, okay? And it was CPU mostly on the sequential things, and GPU was more parallel things actually. If you look at a PC, this is the most expensive device in the PC. Sometimes it will be crossing the PC cost itself. Okay, that's the market of the GPU. And yeah, GPUs are typically much faster than, and it was designed for specific applications, not like a regular applications. But if you design for an application, you will use GPU for that particular task, what you wanted to do, very fast actually. Okay, so mostly it was in the video games and 3D modeling and editing and all the stuff. Recently, if you look at last 2-3 years, it was capturing market majorly generative AI workloads actually. And yeah, this is pretty standard slide you will see anywhere in the internet. What is the CPU between GPU? But major things is that the number of cores, what you see in CPU was very limited because it happens in sequential processing and all the stuff. The GPU you can see it will be thousands of cores actually. So that if you're looking at a mini multi-thread application, you can actually, each thread can give each core and it can perform simultaneously and it can provide the output for you more faster actually. So that's the difference majorly. And traditionally CPU used for certain applications like Words, web browser, and all these applications. And GPUs are majorly used for the video games, video editing, and generative AI actually. So yeah, I think there are so many presentations happen on this one. Yeah, I don't need to really explain this one. What exactly generative AI? I think any area what we are seeing now is basically to generate the content more faster and more easily, and using the traditional knowledge what we have actually. Okay, so what exactly it do? It learns from the past data, and when you ask something, it actually use that data and able to answer for your query actually. Okay, so there are majorly two things happens in the backend. That's what you will heard it. Basically, it's called one is training, another one called inference. Most of times, what we do in the real world is basically inference. Training is basically it's a huge task happens on parallel GPUs at the same time to learn a lot of data and creating the model. So if you look at recently, the Facebook Llama 3 was released. It was ran on billions of CPUs at the same time in the backend. So training is one thing which is basically one-time activity which will be running at reading the data and understanding and creating the model. Inferencing is basically multitasking, real-time inference it's called. What you call, you go to ChatGPT and you ask some question, it responds to you, that's basically inference, okay? You ask and it'll respond back to you. And that's what we see mostly, image generation or a text formation or anything. What we're seeing is basically in the real world is basically the real-time inference, but the training is completely different activities runs on the parallelly and it's a heavy task at the same time. So in the demo, we will cover more on the inferencing things. So there are a lot of wide applications. If you look at in industry right now, there are wide number of applications available for the generative AI. Majorly categorized like a 4th-generation application, like, the text completion. You look at the Codium, ChatGPT. These are all majorly the text completion things. You ask a question or you ask something, it responds back to you the answer with the things, actually relevant data. Then we have image generation. There are a lot of things are available, like right now, a lot of traditional image generation softwares, now they started using this AI-based solutions so that they can able to provide the images with the creativity what we ask actually, okay? Apart from that, you have music composition and video generation. This is all, you can ask something, you wanted a video, you wanted a text, you wanted a audio, it can generate actually, okay? With all the learning what he has done with the models actually. I think I'm going very fast, it's okay. So what we do demo now in this presentation, we talk about some of the tools, some of the things which are majorly open source. So if you are interested, if you would like to explore, you can actually use these tools in your PC, on a PC also. But it may be a little bit slow, but you can able to play with these things actually. Okay. One of the 2 examples I'm going to cover, also in the video, in the demo, is basically the Stable Diffusion. Another one is the Dell AI chatbot. These 2 are available in GitHub, and you can install on your PC to practice or any hands-on actually. Okay. So first one is basically the Stable Diffusion. It's in a simple image, text-to-image generation software. Okay, you can ask a prompt, it can generate an image for you. Okay, and it runs on there is a model called Stable Diffusion, as the Stable Diffusion model. It uses in the backend, and yeah, it has REST APIs. It has everything. So if you wanted to put this software on your system and you wanted to do a REST API-based stressing on your PC or a memory, you can do all the stuff with the thing. The next one is Dell AI chatbot. Again, this is a similar like ChatGPT. It is basically, Dell was published this one to the market. It's an open source one. And it's very much, it has a UI and it has an API, REST API, which we can able to access. Again, this is also available in GitHub, which you can deploy on the system and you can able to do. And what it has, this particular chatbot has a capability is that, for example, most of the times what happens, we ask questions, what is already learned, it will able to answer. But what if I wanted to give something to the chatbot and able to learn and able to answer? That's the advantage this one has. So that if you can able to load some of the PDF files of your data, it can able to learn, it can able to answer for that particular data actually. So basically you can add your own data, and when you relaunch the application, the data what you have loaded can be used as a learning, and it can able to answer for the people. That's pretty interesting one actually, if you really wanted to have it. So. Okay, now I talked about the GPU, then I talked about the generative techniques and technologies and all the stuff. Then we just given some demos of some of the tools what we use, text to text and the text to image. So now I'm going to go a little bit more into the system testing. Okay, that's what the core. So I am from the server validation group. What we do basically is that we validate the servers, certifying the servers, and release the systems into the market. Okay, we have different components. You can you can take a PC or you can take a server. We have memory, CPU, networking, storage, like that. We also have GPU as part of server. We test as part of server, and we release that server to the market, make sure that the GPU working fine as part of testing. So we have different phases. I think you guys know all the phases of testing, like a component testing, product testing, system testing, all things. What we're talking more now is basically like a non-functional testing or system testing, you can call it in the basically. What exactly this phase we focus is that, like in any customer, how the server they use, we try to simulate the same customer use cases and workloads in the phase of the system testing and make sure that the system behaves properly and have enough load was able to handle it and all that stuff, we do it. So what exactly this means is that if a customer is going to use database, we will be trying to deploy the database on our system and do extensive database stress, make sure that the system is able to handle all the database scenarios and all the performance and load issues actually. So now, in this situation, what we are trying to do is that now we have a GPU as a commodity and we would like to keep the GPU in the system and we are selling to system customers. What exactly the customer going to use GPU? We will try to simulate the same workloads and try to run it and see. For example, you will secure a ChatGPT now. End of the day, the ChatGPT is running in some system with a GPU in the back end. So that's what we will try to simulate and see if the system is able to run and perform the load properly. So what exactly this do? It is basically the entire life cycle of a data center, a system when it comes up, what exactly they do. We try to simulate all the stuff, but in this presentation, we focus more on the customer workloads, how to simulate. Okay. Otherwise, you got a system, you put it into the data center, you deploy the OS, you deploy the application, then they start putting customers started using the system remotely, and if there is anything happens on the service patches and updates, they do update, then keep monitoring system utilization, system issues. Once the life cycle of system is over, they will be retiring it actually. So in the entire presentation, what we're going to talk more on how we simulate the customer workloads. Basically, we put an application, but we need to simulate the stress so that the workload will be running and performing the system properly, actually. So that's the presentation in the entire system test. This is what we will be doing to simulate, and what tools we simulate, and how do we do it, we'll talk about in the next. Yeah. So when we started, what do you call it, and the entire system test, correct, we use a lot of proprietary tools. You maybe heard about load test, load runner, Ixia, there are NeoLoad. There are so many softwares are there in the industry. We use that to do load testing on our systems actually, but they are pretty expensive. Over the time, it's become very difficult for us to maintain the licenses and all the stuff. That's why we started building our own tool. Again, in this slide, whatever you see is completely open source so that you can play with that tools and we can play with the softwares in your system actually. So what we build is we build a solution. It's called JAS, JMeter as service. And what it can able to help you is that it can able to bring the containers with the JMeter script, which actually stress your application. It could be database, it could be generative AI, it could be a web services actually. So I will talk about more tools in the back end, but what exactly this can help us is that we can able to integrate our workloads, what we want to do. Like recently we got a generative AI workloads, we're able to easily integrate it. And yeah, it has a REST APIs and data dashboards where we can able to visualize all the data and access the data actually. Yeah, majorly this runs the core, what do you call it, we run it on JMeter, using JMeter. I'm sure some of the people may be using the JMeter as part of things. What we do is we have a JMeter scripts packaged into the container and scale the containers such a way that if you ask 1,000 users, we will bring 1,000 users with the containers which will be stressing the application at the same time. That's the scale of things it will take care. So yeah, these are the technologies. Again, everything what you see in the slide, you can able to, it's open source, you're able to deploy in your lab and no need to pay any license, no need to do anything actually, okay? The first one is JMeter. I think, yeah, I talked to you about all the things. It's a multi-threaded software. It runs, it's a platform independent. You don't need to really worry about which OS we need to build. And it supports multiple load tests and there is a huge community available to get the scripts and to run in your environment. And Dockers and Docker Swarm, it's basically like a small component where we can able to bring the containers, bring the things more faster. It can be reusable and resource efficient compared to the VMs what we use traditionally. Again, the VMs, if you start working with the things, license and all things, you need to really worry. Here it comes completely open source one. And the Docker Swarm, I think you maybe heard about the Kubernetes and all the stuff. We use the native Docker Swarm cluster so that it can orchestrate the containers very fast and it can able to bring it up. And it has, again, REST APIs and load balancing and all things. So why I'm talking to this REST API and all things? We use that in the backend to communicate to the clusters and bring the containers and run the stress actually on the SUTs. System unit test. The last one is basically Elasticsearch database, which will be storing all the data what we are running the workloads, the transactions, the issues, the performance things, metrics and all things we store there, and we use the Grafana to monitor this data and visualize to the end user. So these are the major softwares, and we use a lot more softwares like a PortRainer and all this stuff. But again, all these softwares are open source so that you can able to use it in your regular projects if you want to explore as part of the things. So yeah, this is little bit high level design, how exactly it happens and what the scale it will handle and how it works out. So when a user, there is a React-based front end we created, it's a little bit lightweight application we created, where user goes into this particular portal and they says that we would like to run a GENERATIVE workload with so many users on this particular system. So what it do is that it goes and submit the request to the cluster. Everything happens in the backend. Everything is through the REST API calls. It will take care. So it goes into the load generator and asks you, saying that, okay, we want to run so many containers with so much of stress. So what it happens is that once the service comes, the load generators will come up with containers, basically the JMeter scripts which contains, and they will launch, and they will start stressing your system over the network. So if you are talking about a generative AI application deployed on your system, so they will be talking to the system over the REST API calls and ask for a multiple prompts or the text to image and all the things actually. Once this happened, all the data, what was generated as part of the load generators and containers, as well as the system on a test, will be sending to the database in the live. And this data will be useful, and users will be monitoring this data using the Grafana dashboard. Yeah, what's the time we have actually? I don't know. I think I covered very fast, but I wanted to, most of the times I would be interested to have Q&A session and I want to talk about on things. But you have, how much time you have actually? Yeah, something. Okay, that's fine. No, I just wanted to go for the demo, that's why. So, I think it is now, let me see how it will handle it. Okay, so this is very lightweight front end. Okay, we just wanted to make sure that to start the jobs, we created this front end where users will go. Okay, this is the chatbot application I talked to you guys from the first slide. Okay, you guys can able to use this and download and install on your system also. And it has all the documentation, how to start and all the stuff. Okay, and this is the chatbot application will be launched after installing on your system. And I'm just trying to put a question saying that, can you talk about one specific server? And that's what we already loaded. So it will provide all the details like in that what it is getting. It's basically talk about that particular server. It just goes and asks for a server, and it responds back with the data. And if you can see this side, and it will be trying to stress the GPU. We have the GPU called Nvidia H100. It's one of the most powerful GPU. So once you ask the question, it runs in the back end, it processes the request, and respond with the results. And at the same time, you can see there is a spike on the GPU actually. So what we do is that we try to generate hundreds of queries parallelly on the GPU at the same time using this application, using our solution, so that your GPU will consistently stress down your backend. So this is another UI, another tool. Basically, this will be help us to generate the text to images. This is also again open source one, and you just see that if you can request a text to image with particular prompt, and then it will generate that image in the backend, and that's what you see in the side of the spike actually in the GPU. So these are the tools what you see in the front end. These are tools will be deployed on the cloud, and they will be providing as services for the end user. So the people will be using these technologies to get the data for their purposes. So I'm just trying to, what I did is that we went ahead and we went to the tool, and we just give that IP address of the system and asked to run a chatbot workload. So what it happens is that it creates a backend, a service, saying that, okay, you asked particular number of users, so it creates a Docker container in the backend. The container contains the JMeter script, which will be talking to your chat generative AI application and start sending the prompts to request more and more data actually. So you can start seeing that basically this is another tool which is backend where you can see all the stuff, what is happening in the cluster. So you can start seeing the spike here because the container what we requested started asking prompts continuously, and that using because of the prompts, the GPU started processing and responding back to the all the results. So it started spiking the entire system actually. So you can see the system's utilization data from there, and also the entire GPU utilization here actually. So this is the way what we do is that we continuously test the GPU for almost like a 120 hours over the time, and see that how the system is able to respond, how the GPU is actually performing all these tasks. So right now what we are trying to do here is that we are using generative AI applications to stress the GPU, and that's the reverse engineering where we make sure that the GPU performs perfectly or not over the time. So now we also trying to do some things like, it was only 70%, but we want to hit 100%, and we can increase the number of chat GPT users, or we can also run a parallel application. So in this demo, what we're doing is that we are running another parallel application, which is basically the text-to-image text-to-image generation application. So again, we asked Ender, can you run this particular application? It started running in the back end. So now you can see that the GPU utilization become 100% because now you are running two applications at the same time, and there are 8 users running in the back end who are continuously asking for the prompts and text-to-text based prompts and text-to-image based content. So you can see all the 100% utilization action. So this is the way where how we can actually run the multi-applications on the same GPU and stress the GPU at the same time. And if there is not sufficient, because if the GPU is very powerful, we can actually add number of users, and it can scale down, scale up, which actually sends more requests to the GPU, more requests to the application. Eventually, the GPU get more stressed actually. So this is basically what we are trying to do, is that how the GPU will be used in the customer in the real world. We will be trying to use same way, but we can't use we will be using the JMeter and containers to simulate the real world customers or real world users actually. Okay, so yeah, this is the way we will be continuously stressing, and then once we have that time period for the stress time, basically 120 hours or 5 days, and then we will be trying to stop the workload, and it will melt, cool down, and then we will be monitoring the system, how it performed and how it is using actually. So this is just a generative AI workload we given, but we have multiple workloads like a database, mail, all the workloads we run, and we will try to stress the system continuously, and we will do actually. Yeah. Earlier we used to use the proprietary tools. That's become very expensive for us to do because we have a scale of systems we work at the same time and scale of number of users we needed. And that cost a lot of license for us. So eventually we build our own open source solution with all the open source tools. And with the generative AI workload, we are able to seamlessly stress the system actually. I think, yeah, I can't exactly put the numbers, but over the last 5 to 6 years, we saved around $5+ million of the money to do this particular testing in our own lab using our own hardware actually, instead of going for a proprietary tools actually. That's the business case for us to do. Okay. Yeah, I think I covered. I know I was a pretty rush, but you can feel free to reach me or reach us. I can able to provide more details, and I can able to, if you guys wanted to do something on your own company or help you guys, I'll be really happy for that purpose. Okay. This one? Yeah, it's all available. This is basically a command line tool on the GPU to monitor the GPU utilization, and all the tools what we deployed is also open source, and the tools which we built on top of that, on top of the open source tools actually. Okay. Yeah. Yeah. This is in on-premises. Sure, I'll do that. So, on-premises, yes. So, if you look at it, correct, if you want to stress a system, we need to have another system to stress actually, because it's basically like a client-server architecture. So, we have our own servers who we install the Ubuntu and we install the Dockers on top of that. We configure them cluster, then we do, because yeah, we can't put it in the cloud because again that network latency issues and all the things we face. If we wanted to have a heavy network traffic, we have like a 100 gig network traffic we needed to have. So everything inside the lab where we are actually use this particular solution and test the systems. Yeah. They're also in the same lab. Same lab, yeah, absolutely. Yes, yes. This is completely because it's like it's like a lab system engineering lab, which have high-end networking, high GPUs, high load generators, which generate the system. All the things will be there. Yeah. Yeah. Go ahead, please. Correct. So I think when the GPU started getting into the market itself, they will have something called a technical marketing team, and I'm not called quality team, who actually finds out which GPU is for the which use cases. For example, certain GPUs are only for the chat GPT use cases. Certain GPUs only designed for the training purpose because they're very extensively used for the multi-cluster and multi-things. And right now I showed the demo where you have a one GPU in the one system. We have a use cases with one system with multi GPUs, at the same time multi systems with multi GPUs. So we deploy these applications one on all the systems and configure with the clustering so that, and we will be keep requesting with the users with all the prompts, and this will be distributed in the back end, able to respond back to us. But mostly it will be comes from the technical marketing team and quality team for us. We don't choose the workloads for the GPUs. They says that what is the market proposition for this particular GPU and what is the market proposition of the server. Then we design the workloads and we run it on the system. Um, Something very much closer, but we look at it more on the GPU performance, not GPU performance, GPU stability. Okay, let me put this way. Okay, once you say performance, the transactions and these things numbers will come up. We will be more on the stable of the integration of the system, integrated the GPU, how it works. We will be more qualifying that one.
Could you use your system as a baseline and then point it at something running on AWS or Azure and then just compare the results?
We can do that, but some one extent what we have a challenge is that the network latency, because when we will be running like a 100 gig network pipe to test the systems, but once we put it in Azure or any other cloud, we may not get that much bandwidth from the systems. So we run mostly on the on-premises with a high network traffic actually, because the GPU system will have a 100 gig card, very high network card, and the system, the load generators also will have similar cards to meet the traffic requirements actually. One of the major challenges that if you look at it, the cloud-based solutions which generates the load, the network is one of the constraint for us because we won't get so much of network traffic to send the pipe, send the stress.
Can you simulate latency?
Hmm?
Can you simulate the latency?
Some extent actually, okay? Because here what we focus more on with heavy traffic, how exactly the device is performing is what we look at it. Okay, yeah, at the end of the day, if you have a latency, how it will be handled also one of the things we will look at it. But if you have a network card with 100 gig network card, if we stress all the 100 gig, how is the device is able to handle? How is server is able to handle? So that's where we will be very close to the system and the load generators and stress the gen. Again, we will be having different use cases. If we have a network, it's different. For example, if you have CPU, sometimes we may not require so high network, because if you deploy a database on the system and ask saying that I want to search for a data requirement, you don't need to have a heavy network request, but the database will use a lot of data to search and come back. That may take a lot of CPU cycles in the backend. Yeah, it's based on the design, what exactly the workload. It's not like all the workload, one workload able to use all the components stress. Basically, when you look at it, CPU means CPU workload, GPU means GPU, and again, that workload also mostly what customers uses it in the backend. I mean that it's we the backend in the backend. If you look at it, it will be maxed out. It will be always runs 100%. But what we also look at it is that how the system is performing, the fans, the thermal, all the things we will monitor it, saying that how it is getting used actually. Because sometimes what happens, the fans may not able to handle. Because the fans issue, GPU may be slow down. So we look at entire ecosystem and see how the system is getting performed under this particular load situations. Yeah. That's all. That's the one of the big game. Make sure that the system is actually abruptly crashed, be a blue screens, all the things should not. We are basically like a system testing team. The system is going to the. Yeah. Yeah. Feel free to reach me if you need any more questions, any more thing. I'll be happy to answer you guys on the offline also. Okay? Thank you. Thank you very much.